All right, so we're looking at page 345, section 4.7. Page 345, section 4.7. All right, section 4.7 is a 2-day section. We will work on it today and tomorrow. 4.7 is inverse trig functions, and it's really based on several things that we've already been doing. It's, in essence, something that we've already done and one step less than it. So that will make life simple. All right, to begin with, we've got this chart up here at the top that we've been working on. Remember that we have the cosine and the sine values, and that from that we could also build our tangent values. Like you could do sine divided by cosine is equal to tangent, sine divided by cosine is equal to tangent, sine divided by cosine is equal to tangent. Additionally, once you find one of the tangent values, either square root of 3 or square root of 3 over 3, the other one is just the reciprocal. So there's really not a need to do that division work twice if you don't want to. But that chart will be very helpful for us today. Okay, so the first example that we have up here, it says sine theta is equal to -1/2. Okay, we've done this type of problem before where they would say, tell all the places that sine is equal to -1/2 between 0 and 360, or between 0 and 2 pi, depending on whether they wanted us to use degrees or radians. All right? We had two ways of doing that. One, we could draw out the entire unit circle and just look at the unit circle to see where that was true. Or two, what most of us may have preferred as an option of a 5-minute, circle drawing, was to do the two-step process where we would use our reference angles to come up with this. So here's how we did that. We would go through and say, okay, I need to figure out where sine is equal to 1/2. So I'm going to come over here to my chart and see, there it is right there in my chart. Sine is equal to 1/2 with a reference angle of pi over 6. So at pi over 6, or 30 degrees, is where sine is equal to 1/2. Then we would say, where is sine negative, since this is supposed to be a -1/2? And we would say sine is negative in the third quadrant and the fourth quadrant. So we would give the third quadrant that had a pi over 6 in it, and we would give the fourth quadrant angle measure that had a pi over 6 in it. All right? What we want to look at today is inverse sine, inverse cosine, and inverse tangent. Those are inverse trig functions. And when we're looking at inverse sine, we're going to do a problem very similar to that. When I talk about the inverse of a function, remember, for a function to have an inverse function, then it has to pass both the vertical and the horizontal line test. It has to pass the vertical line test to determine that it's a function, and it has to pass the horizontal line test in order for its inverse to be a function, right? So if I look at inverse sine, and I think about the sine curve, if I were to go through and draw vertical lines, no problem with that. It does pass the vertical line test. Yes, it is a function, but it would miserably fail a horizontal line test, right? I'm going to hit my graph in multiple spots. But I need inverse sine. And so in order to be able to use the inverse trig functions, we're not going to be able to use every value in the domain, all real numbers in the case of sine and cosine. We're going to have to restrict our domain. And so the restriction for sine is that I'm only going to use the piece of this curve between -pi/2 and +pi/2. Because if you notice, if I look at just that little piece on the curve, then yes, that would pass a horizontal line test, so there would be no problem with that. So if I'm thinking about the piece between -pi/2 and +pi/2, all right, let's think about our unit circle. Okay, if we've got our unit circle and we're trying to think about the piece between pi/2 and -pi/2, that would mean start at 0 and go up pi/2, start at 0, go down pi/2. That would just be the first and the fourth quadrants, right? And so for that reason, when I'm working with inverse sine, I'm only going to use the domain between -pi/2 and +pi/2, so that means I'm only going to be working in the first and the fourth quadrant. Now, the way that I'll know that they want me to do inverse sine is they'll either write sine -1 or they'll write arcsine. We've talked before about how sine -1 might accidentally be interpreted as 1 over sine or cosecant. And so in most textbooks, they'll use a capital S there to make sure that that avoids any misreading. Our textbook doesn't do that, but to help you on tests and quizzes and that type of thing, I will type it that way, or I use a capital letter instead of a lowercase letter. They're very clear in the textbook when they are referring to inverse trig functions to avoid any misreading for us. So we come down to our first example, and they ask me, find the inverse sine of a negative 1/2. So according to this definition up here, when I'm doing inverse sine, I'm doing Jeopardy. I'm doing the opposite of taking the sine of something. Okay, so when I'm doing inverse sine, I'm saying sine is equal to the value, in this case, negative 1/2. So sine is equal to negative 1/2. I also know by the definition that my domain is restricted so that I'm only looking in the first and the fourth quadrant. So I get all of that from the definition. When I see inverse sine negative 1/2, I'll automatically know that means sine equals negative 1/2, and I only have first and fourth quadrants to choose from that definition. Okay, so then I can go through and say, either I'm going to draw my whole unit circle to figure out where this is true, or I'm going to use reference angles. So let's use the idea of reference angles. Where is sine equal to 1/2? Well, I'm going to go back up to that chart at the top and say, there it is right there. Sine is equal to 1/2 at pi over 6. So pi over 6 is going to be my reference angle. Now, typically at this point, we would say, where is sine negative? Sine is negative in both the third and the fourth quadrant. That's what we did up here, right? Exact same problem up here just a second ago that we were using to review. We said, where is sine negative, third and fourth quadrant, and we gave both of those answers. Here's what's different about inverse sine. Because inverse sine is only valid in the first and the fourth, I can't get a third quadrant answer. Because inverse sine is only valid in first and fourth, I cannot get a third quadrant answer. So literally, I get to throw that third quadrant out the window and just give the fourth quadrant answer. So I get to do less work than I did before. Exact same problem that we've already learned how to solve, one less step, a little bit less work to do. Okay, so we said, where is sine negative, third and fourth quadrant? It can't be third because that's not in my domain, so I'm just going to give the fourth quadrant answer of 11 pi over 6. Now, you are welcome to give 11 pi over 6, but if you think about it, if we're starting right here at the positive x-axis and we are going down pi over 6, because our reference angle is pi over 6, that means goes pi over 6 away from the x-axis down into the fourth quadrant, right? So if I go pi over 6 away into that fourth quadrant, a way of thinking of that would, if I go down pi over 6, that's just a negative pi over 6, right? Well, negative pi over 6 and 11 pi over 6 are the same thing. And it might be easier to come up with the negative 11 pi over 6 because you don't actually have to like count all the way around the unit circle to 11 pi over 6. And honestly, it's really a better answer. I will accept either one of these, 11 pi over 6 or negative pi over 6, but if we were going to be really technical here, if you look at the domain between negative pi over 2 and positive pi over 2, negative pi over 6 is within that domain, 11 pi over 6 is not. So your college professor may only accept this answer and count this one wrong. I understand those are the same thing. I'm not trying to terrorize you as we're just learning this stuff and we're only 2 weeks into it. I'm just happy when you come up with the right answer right now. So, you know, I'll take it in either form, but understand that this negative pi over 6 really fits this domain restriction better. All right, look at the next one. For the next one, we've got Arcsin 1 half. So when we see that, by definition, we know that that means sine is equal to 1 half, and we only have the first and the fourth quadrants to choose from. That's the definition of inverse sine. So again, I already have talked about sine is equal to 1 half right up here at pi over 6, so I've got my reference angle. Typically, when I did these problems before, I would have said, where is sine positive? Well, it's positive in the first and the second quadrant, and I would have had to have given both of those answers, a first quadrant answer and a second quadrant answer. Because inverse sine is only valid in the first and the fourth, I'm only going to give the first quadrant answer. I'm going to throw second quadrant out the window and cut my work in half. So I'll just give the first quadrant answer of pi over 6. All right, so we could have a similar discussion for inverse cosine. just like we had for inverse sine. For inverse cosine, anytime I see the notation arc cosine or cosine to the -1, that's going to be inverse cosine. Now, if you look at the cosine curve, it's going to pass a vertical line test with no problem, but once again, it's going to fail the horizontal line test. So if it fails the horizontal line test, I'm going to have to restrict its domain. I do not have the same restriction on cosine as I do on sine. What, are they just trying to be complicated? No, if you notice back here, the restriction that we used for sine was from -π/2 to +π/2. If you used from -π/2 to +π/2, would that pass a horizontal line test? No. So I'd still have the same problem, right? I wouldn't have fixed my problem. So I have to use a different piece. I'm going to use the piece from 0 to pi when I'm working with inverse cosine, because you can see that piece would pass both a horizontal and a vertical line test so that I could have an inverse function there. All right, now again, if I'm thinking of this on a unit circle, if I were drawing out a unit circle and I'm thinking about where is from 0 to pi, 0 is right here and pi is right here, right? So we're just talking about the first and the second quadrant if I'm drawing this out on a circle, okay? So for that reason, when I use inverse cosine, it's only going to be the first and the second quadrant. So when they give me arc cosine is square root of 3/2, by definition, I'm going to know that means cosine equals square root of 3/2, and I only have first and second quadrants to choose from. I get all of that from the definition. All right, so I'm going to say, where is cosine equal to the square root of 3/2? So I can come up here to my chart again and say square root of 3/2 cosine value, that's right there at pi/6. So my reference angle is going to be pi/6. Then step number 2, I typically would say, where is cosine positive? Cosine's positive in the first quadrant and the fourth quadrant, so normally I would have to give both of those answers. However, because the inverse cosine is only valid in the first and the second, I literally get to throw the fourth quadrant out the window, cut my work in half, and only give the first quadrant answer. Now, let's make this even a little bit shorter. If you notice back here for inverse sine, first and fourth quadrants, one of them is positive, one of them is negative. Cosine, first and second quadrants, one of them is positive, one of them is negative. All right? So let's say that you're back here in this very first example that we were working with, and you get sine is equal to -1/2, and you get your reference angle. You don't really have to go through this whole thing of naming both of the quadrants where it's negative and then choosing the correct one. Because honestly, if you look at this and go, okay, it's positive here and it's negative here, since I have a negative answer, I have to be in the fourth quadrant. I don't even need to think about the two quadrants and eliminate one. I automatically know which quadrant I'm in. Same story over here. I'm looking at sine is equal to a +1/2. I know that I'm positive in the first quadrant and negative in the fourth, so since I had a positive, I have to be in the first quadrant. There's no need to name both of them and then toss one of them out. Same story down here. We had cosine is positive square root of 3/2. Positive in the first, negative in the second. I have to be in the positive first quadrant. There's no need to think about first and fourth and toss fourth out. So I can even save myself that extra step. All right, let's talk about inverse tangent. Just like inverse sine and cosine, if you look at the tangent curve, it would pass a vertical line test, but it would fail a horizontal line test. So we needed to restrict the domain. And so we have restricted it to the piece from -π/2 to +π/2. You'll notice that piece would pass a horizontal and a vertical line test. Now, -π/2 to +π/2 for tangent, that's the same region as we used up here for sine. The only difference is we will have equal to with sine, we will not have equal to with tangent, because notice that π/2 and -π/2 is where we have our vertical asymptotes. We couldn't be equal to that. So when we work with inverse tangent, we will use the piece from -π/2 to +π/2. That's first and fourth quadrant, just like sine was, with the exception of we're not equal to it. All right, so let's say that they give me inverse tangent of 0. By definition, That means that tangent is equal to 0, and I only have the first and the fourth quadrants to choose from. I get all of that from the definition of inverse tangent. So that means that tangent is equal to 0. Now, I have that chart on the top of my paper that has square root of 3 over 3, square root of 3, 1. I don't have zeros and ones, and where is this coming from? Well, it has to be coming from those angles that are the divisors of my quadrants. So those quadrant angles that divide, like fourth quadrant and first quadrant, so the 1, 0, 0, 1, negative 1, 0, and 0, negative 1, that are at 0, pi over 2, pi 3, pi over 2, and 2 pi. So I'm looking where sine over cosine, because that's what tangent equals, I'm looking for where sine over cosine equals 0. The only way a fraction ever equals 0 is where its numerator equals 0. So we could make this even a little simpler by saying sine over cosine is going to equal 0 wherever sine equals 0. And then I could just look at my chart and say, okay, where on this chart is my y value 0? Well, that's over here at 0 and over here at pi. Well, think about your domain. Your domain is only between negative pi over 2 and positive pi over 2. It's only this side over here. So it can't be pi because that's not within the domain. It has to be 0. Look at another one of those. We've got arctangent of the square root of 3 over 3. So if you look back on top of your notes for where tangent is equal to the square root of 3 over 3, your reference angle is going to be pi over 6. Tangent is typically positive in the first and the third quadrant, but when I'm working with inverse tangent, I only have first and fourth to choose from. So I can throw third quadrant out the window and do half the work and know that my answer is in the first quadrant, pi over 6. Alright, so the next thing that they're going to ask us to do is to do several of these in our calculator. Up till this point, everything that we've been doing in today's lesson has been by hand. Let's look at how we could do these on the calculator. And grab your graphing calculator and your scientific calculator. Because you know some of the time you can only use the scientific calculator for your test or your quiz, and we want to make sure that you know how to put these in properly. Alright, so for the first one, they asked us to find the arctan of negative 8.45. Now, they really should tell us whether we're to be in degree or radian mode. They didn't specify. Typically in the directions it'll say give all answers between 0 and 360 when they want us in degree mode, or give all answers between 0 and 2 pi when they want us in radian mode. They didn't specify. By default, put your calculator in radian mode unless you're told to do otherwise. In advanced mathematics, we live in radian mode. In AP Calculus, we seldom switch our calculator out of radian mode. So let's just put it in radian mode since they didn't specify for us here. So be sure that you're in radian. If you're in degree, go to radian and hit enter. And then we can quit out of that. And if we want to do arctan, remember we've done this before, but we're going to do second tan for inverse tan. And then we could put that value in. So we would have negative 8.45. And you should be getting negative 1.453001. Try that on your scientific calculator as well. Make sure that you can get your calculator into radian mode, that DRG button, and see the sequence of steps that you would need to type that in to come up with that same answer. All right, second one that they gave us was Arcsin. So second sine will give us our Arcsin of 0.2447. And make sure that you're coming up with that value. All right, and then the last one that they gave us was arc cosine 2. So I'm going to do inverse cosine of 2. And when I do, I get an error message. And it says error domain. Throw that into your scientific calculator and see what the error message gives you there as well, so that you'll know how to recognize it. Here's our problem. When we typed in inverse cosine of 2, we got an error message. The reason for that is it can't be done. If you think about it, what I just asked my calculator is, where is cosine equal to 2? I know the answer is 2. I don't know what the question is. What's the angle that when you take the cosine of it, you get an answer of 2? How high does cosine go? Goes up to what and down to what? 1, right? It goes up to 1 and down to -1. So where is cosine equal to 2? Nowhere, unless you've had an amplitude change, unless there's a 2 out in front of that whole function. There is nowhere that cosine equals 0. Or, I'm sorry, there's nowhere that cosine's equal to 2. So that's why we're getting that error message. It can't be done. It's not possible. There's no solution. So again, try that on both the graphing and the scientific so you'll know what that error message looks like in case something like that came up again. So again, just for review, we put into our calculator inverse tangent of the answer playing Jeopardy, right? Hitting our Jeopardy button, and this was what we got. Same story, we put in inverse sine, and then we did inverse cosine, and that was the one that we got an error message. All right, so here is your homework for tonight. On pages 351 to 352, we're doing 8 through 15 all with no calculator. Then 19 through 23 odd, challenge 31. Now, on that 8 through 15 all, you should be getting answers like pi over 6 or 11 pi over 6 or something like that. Not a decimal because you're doing it without the calculator. However, when you look in the back of the book, the answers in the back of the book are in decimal. I don't want you converting your answer. Leave it in that pi over 3 or pi over 6 or, 5 pi over 4 or whatever it is that you might be working with. Do not convert it over. Okay?